This is the Reader's Theater called One Giant Leap from Mr. Paul's in Miss Keating's room.
On July 20th, 1969, humans walked on the surface of the moon. For the very first time, black and white images of the moon's surface flashed on television screens everywhere. The whole world was watching. Let's journey back to that time for a first-hand account of that historic event.
This is Jane Wilson reporting live from the Mission Control Center in Houston. As you know, 4 days ago on July 16, Apollo mission left off from Cape Canaveral, Florida. The 3 astronauts on board have traveled 240,000 miles or 400,000 kilometers to the moon. In just minutes, they will attempt the first moon landing. Their spacecraft is separated into 2 parts: the command module Columbia and the lunar module Eagle. Columbia is piloted by Mike Collins. It will orbit the moon, while Eagle, piloted by Neil Armstrong and Buzz Aldrin, makes the historic landing. Let's go to Pete Brooks in the studio for a historic perspective.
Thanks, Jane. I'm here with Dr. Vargas. He is an expert on the history of the United States space program. Dr. Vargas, why is this mission so important?
For years, Pete, the United States competed with Russia to have the best space program. All started on October 4th, 1957, when the Russians launched Sputnik, the first satellite. Then on April 12, 1961, Yuri Gagarin, a Soviet cosmonaut, became the first person in space.
Americans were taken by surprise.
Absolutely, they felt defeated.
What turned things around for the U.S.?
In 1961, President Kennedy challenged us to put a person on the moon by 1970, and today the world is witnessing our effort to fulfill that challenge.
Thanks, Pete. No, thanks. Thank you, Dr. Vargas. Now let's go back to Mission Control and Jane Wilson. Jane, are you there?
I am Pete. The command center at Houston is a huge room filled with workstations. At many of these stations, Mission Control Center experts monitor important data coming from the Apollo 11 spacecraft. You can feel the tension in this room. Right now, I am standing with some special visitors. With me is astronaut Mike Collins, wife Emma, and their 2 children, Todd and Amanda. We are joined by 2 mission control experts. Can you tell us what is happening now?
We're standing in our communications area. This is where we monitor the instruments on Columbia and Eagle.
Wow, I've never seen so many computers before. If you think these are impressive, you should see the Columbia command module. That's where your data is now. Behind the command module is the service module. That's the part of the ship that holds fuel, oxygen, and navigational equipment.
We're really proud of our dad.
Would you like to speak to him now? We have Columbia on our radio. Here, say hello.
Hi, Dad.
Hi, kids.
I wish we had a telescope that could let us see them.
Todd, the most powerful telescope in the world couldn't see something as small as Columbia. It's too far away.
Your mom's right. Think of how far away your father is. This rocket goes 24,000 miles per hour, and it still took him 2 days to get to the moon.
My dad went 24,000 miles per hour. That's right, and do you know why? There's no air and very little gravity in space, so you can travel very fast. Newton's first law of motion states that once you are moving, you won't stop or change direction unless a force acts on you. In a car, friction with the ground constantly slows you down. In an airplane, air resistance works against you for motion. But in space, there's nothing to stop you.
But because there's air and gravity on Earth, it took tons of fuel to lift off, right?
Right. Remember, the rocket that launched this mission had 3 stages. The first stage has 7.5 million pounds of thrust. That's a lot of power. The rocket pushed off the ground on a jet of superheated gas. The second stage needed less than half the power because the rocket was lighter after all that fuel burned off. The third stage was the smallest, even though it carried the astronauts farthest.
But if there's no air to push against in space, how does the rocket move forward?
Good question. That's Newton's second law of motion. Every action has an equal and opposite reaction. When the exhaust gases leave the rocket, they push back and the rocket moves forward on the liftoff. The forces of the exhaust gases moving down propels the rocket in the opposite direction up with the same force.
Dad, you still there? What did it feel like lifting off? We're 3 miles away and we felt the ground shaking.
It squashed us in our seats until we could barely breathe. It added G's, or gravitational forces. Right now, Mandy, you feel 1 G. On liftoff, we felt 3 G's. It was like being at the bottom curve of a roller coaster.
Cool. You need all that thrust at liftoff because the rocket is so heavy.
But it almost weighs nothing in space, right?
If your dad wanted to, he could push the ship with his hands.
That's pretty amazing, isn't it, Amanda? Mom, didn't you say that Buzz and you won't weigh much on the moon?
Yes, I did, Amanda.
Your mom's right. Another one of Newton's laws says that gravity attracts all masses to one another, and the greater the mass, the greater the gravity too. The moon's mass is about 1/80th the mass of Earth. Its gravity is about 1/6 the gravity of Earth. On Earth, the 2 astronauts who will walk on the moon each weigh 360 pounds with their spacesuits on. On the moon, they only weigh 60.
I'm sorry, but I have to interrupt you now. We have the lunar Molly on the line. Neil, what's your status?
We're approaching the landing site. It looks pretty rocky. I keep moving to see if I can find a smoother spot.
This is Jane Wilson reporting. For those of you who just joined us, we are here live at Mission Control Center in Houston. Neil Armstrong and Buzz Aldrin are about to touch down on the moon in the lunar module. In just moments, if all goes well, they will step into the vacuum of space, relying on their spacesuits to protect them from the harsh conditions. In case you are wondering, the moon can be a scorching 243 degrees Fahrenheit during the lunar day and a frigid 279 degrees below 0 Fahrenheit during the lunar night.
Eagle, this is Mission Control. You'll have to set down soon. You're low on fuel.
Roger, Mission Control. We found a landing spot.
What happens if they crash?
The Eagle is moving. Look, the Eagle is moving very slowly. A crash would probably only break the legs. The section with the legs remains on the moon.
There's absolute quiet here at the Mission Control Center as everyone leaves.
Mission Control. This is Tranquility Base here. The Eagle has landed.
There you have it. The Eagle has landed. Those are the words of Neil Armstrong. The first words spoken from the moon. The lunar module has just landed on the Sea of Tranquility. One of the dark areas on the moon that is visible from Earth. The astronauts will now prepare their life support units for the first moonwalk.
Amanda, the life support units have oxygen tanks and water and all the radio equipment in big backpacks.
I know. Dad told me the spacesuits cost more than $1 million each.
The sun flares on their helmets are made of gold foil. On the Earth, the atmosphere blocks most of the sun's rays, but on the moon, the sun would burn their skin in a few seconds. The spacesuits also keep the astronauts at the right temperature.
You've been teaching them everything, haven't you, Mrs. Collins?
Oh,
This is one of the greatest scientific achievements of the century. I want them to remember everything.
I'm ready to open the hatch now. I'm taking out the camera and turning it on.
What you now see on your television screens is live footage from the moon.
Neil will have to jump the last 3 feet to the ground. We had to make the ladder short to save on weight.
I can't believe this is actually happening.
I'm stepping onto the ladder now, down to the bottom step.
The images of Neil Armstrong climbing out of the lunar module are among the most famous in the world. His spacesuit was buckling and his movements were awkward in the low gravity environment. He stepped cautiously down the ladder, hopped off the end, and landed on the surface of the moon, he said.
That's one small step for a man, and one giant leap for man.
Very, very fine grained as you get close to it. It's almost like a powder. It's very fine. And step off the limb. It's one small step for man, one